Hello, what is going on? So here I'm going to solve the daily problem for today. Let's see, so flatten a multi-level doubly linked list. Okay, so you're given a doubly linked list which in addition to the next and previous pointer, it could have a child pointer which may or may not point into a separate doubly linked list. These child lists may have one or more children of their own, and so on to produce a multi-level data structure as shown in example below. Flatten the list so that all the nodes appear in a single level doubly linked list. You're given the head of the first level of the list. So this is a diagram of the doubly linked list or multi-level linked list. The multi-level linked list has children sometimes, which is why it has multi-level. There's 1, 2, 3 level list, 3 level multi-level list. And when you flatten, it looks like this. So basically, when you flatten, you go to the next, then you go to the child, and you set this next. Then you go to the next, then you go to this child, then you go next, then you go back, and you go to this next, and then you go back to this one. So this kind of reminds me of a DFS search algorithm. So probably could use a stack for this. And then here, we have the head, 1, 2. Also, there's a thing to know about this inputs and how they're serialized. So here it says how they're serialized is basically you're always going to have one null at the end of a double linked list, but then you have these couple of nulls in front to tell you that this one is not connected to the 1 or the 2. It's connected to the third element because these are null, so it's connected to the third element, which is the 3. So C is connected to 3. This one's connected to the second element from the previous double linked list, previous level, which is the 8 here. So then you have this. How you serialize it. So then if you go into here, this example, so the code that I'm going to use is going to use a stack. So the first thing is append the first thing to the stack, which is the 1. And then I'm going to keep track of prevs. And I'm going to keep track of prevs. So when I pop off the 1, I'm going to set its prev equal to whatever. I'm actually going to use something called a node 0 so that I can avoid an error with using none. And then just at the end of the program, I'll reset the head to none, the previous value of the head. But anyways, so it will do this, create a node that has a value 0. So that's how I initialize prev. So that the 1, its previous value will be node 0. So that means 1 will now point to some kind of 0 node. Originally this was my head. And then now what I'll do is see if this has a children, see if it has a next. So it has a next, so we'll add the next into the stack. So then when we also we need to make sure that our previous value, its next is set equal to 1. So that means I'm going to have to take prev dot next and set it equal to the current node that I'm looking at. And also I'm setting the current node's prev dot prev equals to the previous node. And then at the end of these, after you pop it out and everything, always update the prev to be equal to the current node. And this node, that your current node is the node from the stack that you just popped off from the stack. So you do that. So then when you go to the 2, it's going to set its previous to the prev, so it's going to set it to this one. And then it's going to set the next for the prev equal to this one, because right now, so these are pointers in a sense. So there's a prev pointer to this 1. But we're going to move it over to here. So now the pointer will be here for a prev. And the head pointer is always pointing to the 1. And then for the 2, we're going to then add 3 to the stack. And that's it. It doesn't have any children. So then we'll pop off the 3, and then, oops. So when you pop off the 3, it's going to add a 3, and again, we're going to set this, we're going to move our previous to this node. And this is where it gets a little interesting, because the 3 has a child. So what you do want to do is you want to append both of these. You want to append the next, which is the 4, and you want to append the child, which is the 7. And because the stack is going to pop off the 7 first, so you're first going to pop the 7 and set it like this. And then it'll keep going. It'll go to an 8. And so your stack will be a 4 and an 8. But when you pop off the 8, you're going to add a 4, a 9, and then an 11, because it has a child. So you add its next value for the 8, and you add its child, which is 11. So then you're going to pop off the 11, pop off the 12, and at this point, your prev is no longer up here. Your prev pointer is at the 12, and your stack looks like 4, 9, and that's it, because 12 didn't have a next. So then, when you pop up the 9, it'll add the 9 to it. It'll take the previous pointer and set the previous next node equal to 9, so it's going to get the next here, and then the prev we set equal to the prev, so we get that right there. Hopefully that explains what this does. And then what the code looks like is, first I want to check if the head is none, and I just want to return none. Secondly, I create a stack with the head. I set the previous equal to node value 0. I say while stack, pop from the stack, use the previous a pointer, use that pointer to set the previous for this node equal to where the prev's pointing, and then set the prev pointer its next equal to the current node, and then set the prev equal to the node, update the previous pointer to the current node that we're at, and then we go down, we're going to append, if we have a node.next, we append that first. If we have a node.child, then we append that, and we update that the node.child will be none. We also don't need this because the node.next is taken care of right here. Okay, so then it's going to keep going through here until the stack is empty. At the end of this, because I set my previous node equal to 0 here, I actually need to set it back to none down here, and then return the head pointer, the pointer to the head, and that will give you the flattened double linked list.